Okay, so and one more thing, today there is a exam. Okay, exam in the sense there will be a quiz. Okay, there will be a quiz at 2 o'clock. All has to attend that quiz. Okay, everybody has to attend that quiz. 2 o'clock quiz വെച്ചിട്ടുള്ള അപ്പോൾ പ്രോബ്ലംസ് കൂടെ പ്രിപ്പയർ ചെയ്യുക. പ്രോബ്ലംസ് ഉണ്ടാവും. PPT ഞാൻ അപ്ലോഡ് ചെയ്തിട്ടുണ്ട് ലെൻവൈസിൽ. Okay, you can refer the PPT. പിന്നെ അതുപോലെ നോട്ടും ഉണ്ട്. Everything is there in the ലെൻവൈസ്. You can take the reference. But 2 o'clock you should attend that quiz. Okay, you should attend the quiz at 2 o'clock. Okay, so we can continue now. So mainly we are discussing today. We are discussing yesterday we are discussing about the pumps. So mainly we are having two types of pumps, that is positive displacement pumps and centrifugal pump. Okay, now positive displacement pumps is again divided into two, that is reciprocating pump and rotary pump. Okay, so reciprocating pump, yesterday I have shown you with the video how it is. That means inside the vacuum. Okay, that means a solid cylinder will be there, a plunger will be there. This plunger will be rotating, and by this rotation the water will be passing through the cylinder. Okay, by the rotation or by the movement of the cylinder the water will be passing. So that is reciprocating pump. After that I have shown you the rotary pump. Okay, so rotary pump means you are having rotary blades. Okay, blades are there. Okay, so the blades that they will be moving in opposite direction. Okay, like this you can see in this figure, blades will be there. Okay, so these blades they will be moving in the opposite direction, so water will be passing through here between the teeth of these blades, and it will go to the discharge pipe. So that is rotary pumps. Okay, coming to the next one, that is next category, that is centrifugal pumps. Okay, centrifugal pumps. So this you might have studied. Centrifugal pump. So what I mean by centrifugal pumps? Okay, so centrifugal pump is a pump which actually converts the mechanical energy into hydraulic energy by the virtue of the centrifugal force. Okay, what do you mean by centrifugal force? Centrifugal force means force that pulls you towards the inwards. Okay, whenever you go through any curve, whenever you are passing through any curve, or whenever there is any rotatory motion. Okay, like this, if there is any rotatory motion, okay, so if there is any rotatory motion, there will be a force to pull you towards the core. Okay, to pull you towards the core. So that force is called as centrifugal force. Okay, that force is called as centrifugal force. Okay, so in the centrifugal pump the centrifugal force is acting. The main force or the main dominant force is centrifugal force. That is, it will be okay like this. For example, so if there is any curved motion, okay, if a particle is going through in a curved manner, there will be a imagine this is a particle. Okay, so there will be a tendency to pull towards the inward side. Okay, there will be a tendency to pull towards the inward side. So that force is called as centrifugal force. Okay, so here in centrifugal pumps, the mechanical energy is converted into hydraulic energy by using the centrifugal force. Okay, so here the flow is in the radial outward direction. Okay, so the flow is occurring in the radial direction. So I am having that video. I will show you. So when you see this, you will understand. Just now understand this concept. I will show you a video. So it works on the principle of a forced vortex flow. Okay, that means a forced rotatory motion. Works on the principle of a forced rotatory motion. Okay, so this can be used for the water, sewage, petroleum, and petrochemical pumping. So here in these areas, mainly we are using centrifugal pumps. Okay. So as you're seeing right now, this is a centrifugal pump. Okay. Okay, now what's the principle of this centrifugal pump? Okay, so main principle is the forced vortex flow, which means that a certain mass of fluid is rotated by the external torque, and there will be a rise in the pressure head. Okay, so what do you mean by forced vortex flow? Means a flow, like means a mass of fluid. Okay, imagine a liquid. Okay, I'll make it will simply I will explain in simple terms. Liquid. Okay, so when the liquid is rotated with the external torque, when the liquid is rotated with an external torque, there will be a rise in the pressure. So due to this rise in pressure, the water will be flowing. Okay, so this process is known as forced vortex flow. Okay, this process is known as forced vortex flow. Okay, now this uh, centrifugal pump is mainly having two main parts. First one is impeller and second one is casing. Impeller and casing. Okay, so impeller converts the driver energy into kinetic energy, and diffuser converts the kinetic energy into the pressure energy. Okay, so the impeller, it will be converting the driver energy, that is the driving force, into kinetic energy, and this diffuser will be converting the kinetic energy into pressure energy. Okay, so right now you can see this picture. So this is a centrifugal, this is a picture of the centrifugal pump. Okay, this is the picture of the centrifugal pump. This is a cross section. So this is the veins, these are the veins. Okay, these are the veins. So here the discharge. So I will straightly go to the video now. So see this. So have you seen this? See. So this is called as the forced vortex flow. Mm. So as you can see, this is the veins. Okay, these are the veins which is having plates, and water will be flowing through these veins. And what is happening? The water is rotated by the torque, external torque. You can see in this video very clearly. You can see the water. This is a mass of liquid which is rotated by the external torque. Okay, this mass of liquid is rotated by the external torque. Okay, so by this action or by this pressure energy, what will I'm sorry, when this external torque is acting on this mass of liquid, the pressure of the water will be rising. Okay, so because of this pressure, the water will pass through the delivery pipe. This is a delivery pipe. Okay, this is the delivery, as you are seeing, this is a delivery pipe. Okay, so you can see here. So these are the parts of the centrifugal pump. So this is the casings, this is the impeller, this is the shaft, this is the bearing. See, so this is the exact picture how the water is pumped through a centrifugal pump. So can you see this? Okay, so water will be allowed to pass through. There will be a pipe over here, so there will be a conduit over here. Okay, so water will be allowed to pass through this conduit, and here this impeller will be rotating. Okay, so this impeller will be rotating, and water will be forced into this impeller. Okay, this water will be forced into this impeller. So what will happen? The water is subjected to a centrifugal force. So external torque is applied. So water is applied to centrifugal force. So you can see the water is rotating. Okay, so what is happening when the water is rotating like this? The pressure of water will be increasing. Okay, the pressure energy of water will be increasing, and because of this pressure energy, water is rising to the delivery pipe. We can see here water is rising through the delivery pipe. Okay, okay. So that's about the centrifugal pipe. See, it will be rotating like this. So this veins initially it will be rotating like this. So water will be passing through it, and then the water will be passing through this impeller, and so that means water is subjected to a centrifugal force. Okay, so the torque will be acting. The torque will be acting. There, how the pressure energy of the water will increase, and water will be passing through the delivery pipe. Okay, so that's how it is working. See, so you can see this is the exact working of this. So here you can see the water, it will be forced through here. Okay, the water will be passing through this pipe. So here the impeller is rotating, and this impeller will be forcing the water. This is the through the delivery pipe. Okay, so water that is coming to the delivery pipe will be having a high pressure energy. See, this is how the centrifugal pump is pushing the water out. See, okay, so through here water is coming. Okay, so this is, so now we can go back to our slides. Okay, so these are the different parts of the centrifugal pump. They will be having an impeller, it will be having a casing. Impeller is a rotating one, casing then a outer part, a suction pipe. Okay, this is the suction pipe is through which the water is pumped through the is called a suction pipe. The pipe through which water is pumped is called a suction pipe. Then there will be a footwall will be there, a strainer will be there, then a delivery pipe. Okay, so now this just now we have seen that how this is working, how the centrifugal pump is working. Okay, so how it is working, the liquid will be, so this is the cross section of that centrifugal pump. Okay, so the liquid, the here the inlet pipe, here it will be the outlet pipe. Okay, so water will be forced to the impeller through the inlet pipe. Okay, and the liquid will be rotating in the impeller, and then it will be going out to the outlet. Okay, so you have to draw this cross section. If the question is asked, you have to draw this cross section, centrifugal pumps. Okay. Now coming to the casings. Okay, then the main purpose of this casings is to convert the kinetic energy into pressure energy. Okay, so mainly the casings is of two types. Casing means the outermost portion. You have seen that video they have shown you with a maroon color casings. That maroon color or outermost box system. So that is called as casings. Now the casings are mainly of three types. That is volute casings, water casings, and circular casing. Okay, so volute casing they are used for the higher head. That is when the water has to be pumped at a very water has to be pumped at to a very height, very big height, large heights. Okay, when the water has to be pumped to a very large height, okay, volute casings are used. Okay, okay. Now next one is coming to the vortex casing. So here the eddy currents of the water will be reduced. That means the hydraulic energy, or you can say the eddy. That means eddy currents means the hydraulic energy of the water can be dissipated by the vortex. Okay, so water will be having a lot of hydraulic energy. Eddy currents will be there. That is, water will be pushing. And hydraulic force and water. Okay, so that can be reduced using this vortex. Okay, next one is circular casing. So circular casings are used for the lower height. That means when the water is need to be pumped to a lower height. Okay, when the water is need to be pumped to a lower height, you can use circular casings. When the water has to be pumped to a larger height, you can use volute casings. And if the water pressure energy is very high, you need to reduce the pressure energy. The eddy currents has to be reduced. In that case, you can go for water casing. Okay. Now coming to the different types of casing. The first one is volute casing. So volute casing is mainly having a curved funnel shape which is increasing in area to the discharging port. Right. Okay, so the volute casing will be having a funnel shape. It will be having a curved funnel shape, and it will be having an increasing area towards the discharge port. So as you go to the port, its area will be increasing. Okay, so as the area of the cross section increases, the volute reduces the speed of the liquid and increases the pressure of the liquid. Okay, so here as the area is increasing, okay, as the area of this discharge pipe is increasing, the speed of the liquid will be reduced. Okay, so speed of the liquid will be reduced, and the pressure energy of this water can be increased. Okay, the pressure energy of the water can be increased. So what is the advantage of this? So water can be pumped to a greater height. Okay, large amount of water can be pumped to a greater height. If the water is having a high pressure energy, it can be pumped to a larger heights. Okay, so in the case of volute casing, the area of this discharge pipe the area of this discharge port will be large. So because this area is large in the discharge area, the speed of the liquid will be reduced and you can increase the pressure. Okay, so pressure energy of the water is increased so that the water can be pumped to a greater heights. Coming to the vortex casing. So vortex casing, it is having a circular chamber. Okay, it is having a circular chamber which is kept between the casing and the impeller. Okay, it is kept normally between the casing and impeller. Okay, so by this you can increase the efficiency of the pump. By this vortex, it is can increase the efficiency of the pump. That is mainly if you want to reduce the water currents or eddy currents. If you want to reduce the eddy currents, you can go for vortex casing. Okay, so mainly water casing is not used for pumping water to a larger heights. Okay, it is not used for pumping water to larger heights, but here our aim is to improve the efficiency of the pump. That means large amount of water can be pumped, efficiency of the pump can be increased. Okay, that means the way the pump is working, that efficiency of this pump can be increased. So that is in the second case, water casing. Coming to the third one, then last one, that is circular casing. Okay, circular casing. So this is a stationary diffuse vane that is surrounding between the impeller impeller periphery that converts the velocity to the pressure energy. Okay, so this circular casing, basically it is having a circular shape. Okay, and this is kept surrounding the impeller of the pump. Okay, you have seen the impeller like blade like things, right? So it is kept over there. So the circular casing will be surrounding this impeller, the periphery of this impeller. Okay, the circular casing will be surrounding the periphery of this impeller, and it will be converting a velocity to the pressure energy. Again, this is not used for larger heights or large projects. Okay, this can be used only for the smaller projects. That means here water can be pumped only to a smaller heights. Okay, so these are the three types of casings that is used based on the height to which the water can be pumped. Okay, now another thing is you have to learn a very important term relating to the centrifugal pump is priming. So what do you mean by priming? Priming is nothing but filling the whole section with the water. Okay, that means it is a process of filling the suction pipe, casings and delivery pipe up to delivery valve is called as delivery valve with water is called as priming. Okay, that means filling the, that is the suction pipe, casing, delivery pipe, everything is filled with water. So that process is called as priming. Why you're doing it is mainly to remove the air content. That is mainly to remove the air content. Okay, so in this video they have clearly shown you that priming process. See, this is the priming. So this is the priming, you can see here. See, so here you can see everything, the suction pipe, delivery valve, everything is filled with water. The whole portion is filled with water. See, can you see the suction pipe? That full chamber is filled with water. Okay, so main advantage of this is that air content can be reduced. If the air is there, efficiency of the pump is will be decreasing. Okay, so the air content can be reduced. So that process is called as priming. Okay, again I will show you one short clip of priming also. Here you can see priming. Serious. So this is a suction pipe. Okay, this is a suction pipe. That's it. You can see. So here this impeller is rotating, but so that because of that rotating, the water will be suctioned inside. See this. This is the exact picture of that priming. Okay, so this is the exact picture how priming is occurring. So everything from the suction pipe, okay, the suction pipe is through which water is entering by the action of suction. So the suction pipe, delivery valve, all these things are filled with water. So this process is called as priming. Okay, so priming is one of the most important process that is involved in the centrifugal pump. So the main objective is to remove the air content. Main objective here is to improve the remove the air content. Okay, so mainly again priming is of two types, that is positive priming is the negative priming is the positive priming means it will speed up the processing, that means the pumping will be speed up, so that is called as positive priming. And if this priming is reducing the process of pumping, it is called as negative priming. Okay, so anyway that portion is not much important to us. In priming, that term is important. Okay, so So that's about centrifugal pump. Okay, so centrifugal pump, one of the disadvantage of the centrifugal pump is that when the water is pumping and if suddenly the water is stopped, if the pumping of the water is stopped, what will happen is that the water will move in the backward direction. Okay, the water will move towards the backward direction. Okay, so some advantages are that's one of the main disadvantage of this centrifugal pump. So remaining, it is very useful because you can pump water to different heights. Okay, you can pump water to different heights. Okay, so you should study this cross section. Okay, this cross section is very important. Coming to the next portion, that is factors which are affecting the selection of the pump. Okay, the factors which are affecting the selection of the pump. First one is capacity of the pump. Okay, so that is how much water a pump can be delivered. Depending on that, you will be choosing the pump. That is, in some way, if you want to go for the larger projects, large amount of water has to be pumped. Okay, so you have to select a high efficient pump which can deliver water to a large heads. Okay, so capacity of the pump is very important. Second one is the importance of this water supply scheme. Okay, so how much important is the water supply? Okay, so based on that, that is, sometimes it will be a continuous water supply, sometimes there will be intermittent water supply. So based on that, you will be selecting the pump. Third one is initial costing. So cost economy is very important. So apart from the efficiency, economy, that is, each and everything should be within the budget. Okay, so initial cost for the some pumping, the initial cost is very high. Okay, so that initial cost is also another factor which lead to the selection of the pump. Next one is maintenance. Okay, once a pump, you have seen the whole arrangement. Okay, yesterday I have shown you a pump station of Rajasthan. So how big the pumping station is. Okay, so lot of engineers, lot of workers are involved on this, so maintenance is very important. Okay, that is, it continuously requires maintenance. Okay, so maintenance, based on the maintenance patterns, for the maintenance you need extra labors. Okay, someone has to monitor it 24 hours, so that maintenance is very important. Next one is space requirement for locating a pump. Okay, so generally you have seen yesterday, like I have shown you that pumping station of the Rajasthan. Okay, so that space location is very important. Okay, some pipe it requires larger area, some pipe it requires lesser area. Number of units that is required, again same related to the space only. Total lift of the water, that is how much quantity of water that has to be lifted. Same thing, the that is lift means to what height it has to be lifted. Okay, to what height, that is, sometimes if you want to pump water to a larger heights. Okay, so correspondingly you have to choose the pump. Sometimes if you want to uh, pump more amount of water, so correspondingly you have to choose the pump. Sometimes you need to supply only less amount of water, or sometimes a medium amount of water. So based on the amount of water, you can choose the pump. Location of the pumping station. Okay, so that is very important. Location of the pumping station, how to locate a pumping station. Okay, so location depends upon the place where it is to receive water, and place where to supply water. So pumping station means the pumping station you have seen, that means where all the pumping process is occurring, that is called as the pumping station. Okay, so where to locate this pumping station, where to locate this pumping station. So this pumping station, it depends upon the factor where the water is, from where the water is received and to where the water is supplied. Okay, from where the water is to be received and to where the water is to be supplied. Okay, അതായത് എവിടുന്നാണോ വെള്ളം എടുക്കേണ്ടത്, എങ്ങോട്ടേക്കാണോ വെള്ളം പമ്പ് ചെയ്യേണ്ടത്, ഈ രണ്ട് ഫാക്ടേഴ്സിനെ ബേസ് ചെയ്തിട്ടാണ് യു വിൽ ബി ഡിസൈഡിങ് ദ പമ്പിംഗ് സ്റ്റേഷൻ. Okay, so based on these two factors, you have to choose the pumping station. Okay, so you cannot choose a pumping station which is far away from the point of source. Okay, you cannot choose a pumping station which is much far away where the water has to be supplied. Okay, so intermediately convenient ആയിട്ട് എവിടുന്നാണോ വെള്ളം എടുക്കുന്നതും എങ്ങോട്ടാണ് വെള്ളം സപ്ലൈ ചെയ്യേണ്ടതും ഇതിന്റെ രണ്ടിനും നടുവിൽ you have to locate the pumping station. Next one is selection of the pumping station. First one is the site should be away from the sources of contamination and pollution. Okay, so if you take about the river will be contaminated. There will be different types of contaminations will be occurring in the river. Okay, dissolved contamination will be there, the floating contamination will be there. Okay, so always choose a station where the contamination of the water is less. ഓക്കെ, അധികം ചളികളോ അല്ലെങ്കിൽ അങ്ങനത്തെ ഒരുപാട് ഒഴുക്കൊന്നുമില്ലാത്ത കുറച്ച് അത്യാവശ്യം നല്ല ഫ്രഷ് വാട്ടർ ഉള്ള ഒരു ഏരിയ യു ഹാവ് ടു ചൂസ് ഫോർ ദ പമ്പിംഗ് സ്റ്റേഷൻ. സെക്കൻഡ് വൺ ഇസ് സൈറ്റ് ഷുഡ് ബി above the high flood level. Okay, site should be located at the high flood level. High flood level means the maximum water. That high flood levels maximum water can be collected at that level. Okay, that is maximum water. Yeah, I think high flood level we have discussed low water level, high water level. So high flood level means the maximum amount of water that is collected in the river. That level is called as high flood level. Okay, so the pumping station should be located at the high flood level so that you can ensure the maximum amount of water into the intake structure. Okay, mostly it is in the upstream side. Okay, if you take a river, mostly in the upstream side you will be having the maximum amount of water. Okay, so you can choose correspondingly. Okay, so you can choose a place where you will get maximum depth of water. Third one is future expansion should be possible. Okay, so always you should, like most of the pumping station will be designed for a design period of 30 years, 30 to 40 years. Okay, so after like 30 years, because the technology is advancing, so the technology that is in the 10 years won't be the technology next to 10 or 20 years. So technologies keep on advancing. Okay, so always you should leave a scope for the technological development. Okay, always you should leave a scope for the technological development. That means when a pumping station is located at a particular place, you should make sure that you should know, you should understand one thing, that after 20 years the technology is going to change. Okay, so that change in technology should be available to this pumping station so that future extension should be possible. So the future extension should be possible. Next one is possibilities of fire hazards should be considered. That means fire attacks can occur. Okay, the fire attacks can occur, so you should always choose a place where fire attack is very less. Proximity to the power source. Okay, you should have a continuous power source. Continuous power source should be there. Should be placed in a neat and clean place. Definitely should have a sufficient space between the stations for the operation, maintenance, cleaning, repairs, everything. Okay, I should always that proper maintenance is required for pumping station. Okay, so for that proper maintenance, cleaning is also very important. Okay, maintenance, operation, cleaning is also very important. Okay, so you should choose a space where all these things are possible. Okay, so that's about the pumping station. Next one is you're going to the conveyors. So conveyors means they are the mechanical devices or assemblies to move water buckets or belt or package with minimal effort. Okay, usually consist of a frame of the rollers where, okay, forget about all this definition. What is conveyor? What is the word meaning of convey? Convey means if you want to say I want to convey something, that means you want to pass something. We'll say convey my wishes. It means just pass my wish. It means just let him know my wish. So that is to convey. Okay. So here, just like the word, conveys means they are the mechanical device which help you to move water from one place to another place. Okay, അതായത് വെള്ളത്തിനൊന്ന് കൺവേ ചെയ്യാൻ വേണ്ടിയിട്ട്. So they are the mechanical devices which help you to convey or which help you to move water, buckets, belts, or package with minimal effort. So that is conveys. Okay. So usually it consists of some supporting rollers, wheels, belt, rotors, all manual rotors. This you have seen in many, like the belt. You might have seen this. Okay, it will be having a supporting rollers, wheels, belts, etc. A lot of things. Okay, so this is also used for the movement of this bulk materials like gravel or aggregate. So mainly we are having these 11 types of conveyors. Okay, belt conveyors is a gravity roller conveyors is a chain conveyors, live roller conveyors, motorized roller conveyors, slat conveyors, overhead hand push beam trolley systems, motorized overhead conveyor systems, power and free conveyors, over and under conveyors, inverted monorail and inverted power free conveyors. Okay, okay. I think almost time now. You can post a name to mark the attendance, okay? Just don't leave now. Just post a name to mark the attendance. Only 27 is there, right? So initially ഇത്രയും പേര് ഉണ്ടായിട്ടില്ലല്ലോ തുടങ്ങുമ്പോ. Okay. Okay, thank you. You can now leave now. Thank you.